Hi everybody. The fourth conic section we're studying is the hyperbola. What I'm hoping you will learn is that given an equation of a hyperbola, you'll learn how to find the center, the vertices, the foci, and graph the hyperbola. So of the four conic sections that we've been studying, the last one is the hyperbola. And the hyperbola has two parts to it. So here's an example in the definition of a hyperbola. A hyperbola is the set of all points in a plane for which the absolute value of the difference of the distances from two fixed points, called the foci, is constant. The midpoint of this segment between the foci is the center of the hyperbola. So see right here, these are the foci, they're labeled F, right? And halfway between the foci, this black dot and this black dot is the center. And this difference between the foci and this hyperbola and the foci and this high point on the hyperbola, the difference between these two distances is constant along every point on the hyperbola. Just like we did in the previous screencasts, we're going to focus our attention initially making the center be the origin. So for these two hyperbola, the center is the origin. And then in the next screencast, we'll move up or down, left or right, we'll move that center. But let's understand it with the center being at 0, 0 first of all. So here are two examples of hyperbola. This time, we're talking about a transverse axis. Transverse axis means the axis that goes through the vertices. So the vertices are kind of like the vertex of this sideways parabola, if you will. And there are two of those because there's two parts to the hyperbola. So the vertices, for example, in this one is negative a0, and in this one is a0. And the vertices here are 0a and 0 negative a. What I want you to notice is how do we determine if our hyperbola are opening to the left or the right or up and down. So I want you to pay attention to the actual equations. And the way you determine that is really pretty simple. It's whatever variable is written first. See, the equation for a hyperbola is a difference between x squared over something and y squared over something. So if x squared is written first and the coefficient of y squared is negative, then we have a transverse axis that is horizontal. That means the x-axis, when the center is at the origin, the x-axis is going through the vertices. So here, the transverse axis is horizontal. In the second example, y squared is written first. And since y squared is written first, the transverse axis is vertical. So it's the y-axis. Notice some of these differences. The vertices and the foci are similar to what we did with the ellipse. That didn't change. But this equation is different. With the ellipse, a squared was the bigger value in the denominator. That's not the case here. It doesn't matter. A squared could be bigger than b squared, or b squared could be bigger. That doesn't matter. Notice the relationship between a, b, and c. Here, it's kind of like the Pythagorean theorem, huh? A squared plus b squared is equal to c squared. So this is different, this equation. It's not the same as what we had with the ellipse. I want to give you some examples. So here are two examples. X squared over 25 minus y squared over 9 equals 1. And y squared over 4 minus x squared over 36 equals 1. And I'm going to give you two graphs. Which graph goes with which equation? That can be determined if you know which axis is the transverse axis. When x squared is written first, the transverse axis is the x-axis. So this must be the graph for the x squared over 25 equation. And when y squared is written first, the y-axis is the transverse axis. So this must be the equation for graph E. Okay, so let's get started. The next thing we need to talk about is this idea of an asymptote. What's different about the hyperbola is that we do have asymptotes here. So for example, if you look here, the asymptote, this right here, this slanted line is one of the asymptotes. Each one of the hyperbola has two asymptotes. The equations for these asymptotes come from A and B specifically. So for example, when the transverse axis is the x-axis, then the asymptote is always going to be plus or minus b over ax. Y equals plus or minus b over ax. And when the transverse axis is vertical, here's one of the asymptotes. Here's the other asymptote. And the equation is y equals negative a over bx and y equals a over bx. So it's plus or minus a over bx. I know that seems confusing and you're going to be like, oh my God, when is it a? When is it b? I'm never going to remember this, but it's easy to remember. Remember, slope is rise over run, y's over x's. So all you have to do is look to see which variable is under y. So here, b is under y, so it's b over a. And here, a is under y, so that's why it's a over b. So just look at what variable is under the y and think rise over run. Okay, let's do an example. Find the center, the vertices, the foci, and the asymptotes. Then draw the graph. So our equation is y squared over 9 minus x squared over 16 equals 1. Do you know which is the transverse axis? You should recognize that y squared is written first, and that means our transverse axis is going to be the vertical axis. That means that our hyperbola is going to look roughly something like this. Also remember the equation for the asymptotes. It's going to be rise over run, a over b, x. Okay, now let's identify a and b, and then we'll find c. So a squared is equal to 9, and b squared is equal to 16. I'm going to plug those into this equation to find c squared. C squared is a squared plus b squared. So plugging 9 in for a squared and 16 in for b squared, I get c squared is equal to 9 plus 16. That means c squared is equal to 25, which means c is equal to 5. Now, don't forget, let's take the square root of 9, which is 3, and the square root of 16, which is 4. So a is 3, b is 4, and c is 5. Now, I'm just simply going to follow these definitions. The center of my hyperbola is 0, 0. And then the vertices, remember, are 0 plus or minus a. So a is 3. So it's 0, 3, and 0, negative 3. The foci are 0 plus or minus c. C is 5. So the foci are 0, 5, and 0, negative 5. And the asymptotes, remember, are plus or minus a over bx. A is 3, b is 4. So it's y equals negative 3/4 x and y equals 3/4 x. All right, great. The next thing we need to do is graph this. I want to do this on another screen so that I can show you how to do this. And I wanted to do this by hand. The first thing I do when I go to graph this is I graph the vertices and the center, the vertices, and the foci. So this is what my graph looks like to begin with. The center is at 0, 0. Perhaps I should have drawn a dot there. But the center is right here. And the vertices, remember, are at 3 and negative 3. 0, 3, and 0, negative 3. And the foci are at 0, 5 and 0, -5. You can see that here. The foci are labeled F in orange, and the vertices are labeled in blue, V. Now here's how I draw the graph. B is equal to 4. So even though that's not a vertex, or they're not vertices, I'm going to draw dots at 4 and at -4. And then I'm going to draw a box. So if you look, remember the vertices came from A, so I went up 3 and down 3. For these dots, I went to the left 4 and to the right 4, and that number 4 came from B. That's not the transverse axis, but the other axis. And then I drew a rectangle through, connecting these dots. And the reason I do that is it helps me to draw the asymptotes. So these dotted lines here, they're not part of my graph, but those are the asymptotes. So remember the asymptotes are y equals 3/4 x and y equals -3/4 x. So here's the asymptote that has a negative slope, and here's the asymptote that has a positive slope. Knowing that my hyperbola has a transverse axis that is the y-axis, I know that I'm going to draw my hyperbola here and here. And this rectangle and the asymptotes are kind of like my guidelines. And so the hyperbola itself is inside there. Okay, so that's how you would do it by hand. I hope that helped. All right. The next example we're going to go through is where we know some information, like we know the vertices and we know the foci, and we're being asked to find the equation. Well, just like I did in previous screencasts, I stress that you should look at your graph. So what I'm going to do is I'm going to graph the vertices and graph the foci. So the vertices are here and here, the foci here and here. That tells me what's the transverse axis. If the foci and the vertices are here on the x-axis, that has to be my transverse axis. So my hyperbola has to look something like this. And so I'm going to be following these definitions. So I need to know what A and B are. And then I'm going to find C. Well, actually, I'm going to use this information to find A and C and use that to find B. So I know A is equal to 1 because of the vertices, right? The vertices are at 1 and -1. And I know C has to be 2 because the foci are at 2, 0, and -2, 0. And then I'm going to plug that information into the C squared equals A squared plus B squared. So 4 is equal to 1 plus b squared, which means b squared equals 3. That's all I need for my equation. So my equation is x squared over 1 minus y squared over 3. Remember, it's x squared over a squared, a is 1, and y squared over b squared, and b squared, is 3. All right, good luck. Email me with your questions.